All right, so now that you guys are comfortable with how to find the distance around a shape, aka the perimeter or circumference, today's video is going to focus on how to find the area inside of these 2D figures, okay? Now up here I still have our formulas, and I want to remind you guys that we've already covered how to go around a square, how to go around a rectangle, and how to go around a circle. So I'm going to cross those out because those go around from the previous video. And today we're focusing on area, which is the formulas that start with the A equals. Okay? So I've got them over here off to the side, and we can use them as we need them to find the area of these figures. All right, let me just turn the cloner on for all of these so that, whoops, I don't want to clone it. I want to turn on the infinite cloner. There we go, infinite cloner. Cool, so then I can just pull whatever I need. So for this first one, we have a rectangle. So out of the formulas, I'm going to need the area equals length times width. And you don't even need a calculator for this because we've just got the 8 times the 3. So this one's going to be a 24 square centimeters. Okay. When labeling area, we consider the two dimensions. We're bound by length and width. So we've got square centimeters here. You might remember for perimeter when we just went around it, we just left it at centimeters. But for this page, we're going to need square centimeters. Okay. All right, now for this one, I do not see a parallelogram up here, okay? But I do see a rectangle. And right now what I want to do is point out that if I were to trace this triangle right here and simply move it over to right here, now in red, I do have a rectangle. So the length of the rectangle is a 6. The width or the height here is a 4. So it is a 6 by 4, 6 by 4. And it happens to be the same answer. So we get 24 square inches. That happens to be a coincidence that it's the same answer as this one. And I just want to point out that again, this takes up the same amount of space as this if I just move it over here. Okay, it's the same amount of space. So whenever you see a parallelogram, y'all, you want the base and the height. It's a 6 and the 4. And you can see that actually we don't need the 5s for the area. We would need the 5s if we wanted the perimeter around it, but I don't need them for this. You've got your base is the 6, the height is the 4, and we just found the area of that figure. Okay? Now for a circle, it's going to be pi r squared. And in this circle, we have the radius is a 4, so it's going to be 3.14. And then the radius is 4, which we're going to square. Friendly reminder in PEMDAS that the exponent comes first. So 4 squared is the 16, and then that is going to be times 3.14. So we get 50.24 for the area of this circle. 50.24. And it was in inches, so I'm going to put square inches. So nothing too tricky so far. All right, we have another circle right here. So I'm going to need the same formula, pi r squared. And the only catch with this one is that the circle, it shows the diameter all the way across. I only want half of that, so I need half of the 21. Half of the 21 is going to be a 10.5, okay? So my radius is actually a 10.5 for this one. The 10.5 is what's going to get squared. And of course, we're going to multiply by 3.14 pi. All right, cool. So I got 10.5. I'm going to square that. Now I'm going to multiply that answer by 3.14. So the area of this one is 346.185. And I'll use this 5 to bump this up to a 19. Okay, since it's a 5, I'm going to bump it up to a 19. So 346.19. And this is in miles, so we'll put square miles. All right, cool. So we've seen a rectangle, a parallelogram, and 2 circles. Now let's talk about the triangles and how the triangles can look different and have a bunch of different numbers. And let's talk about which ones we care about and which ones we need. So for the formula for area of a triangle, it's going to be half base times height. So I'm going to go ahead and put that for both of these because they're both triangles. Okay. All right, now for this triangle over here. So the base of the triangle is this. And then its height is labeled actually over here as the 3. So we have the base and the height. We don't need the 9 or this 6, that would be for distance around it. So we can basically ignore those dimensions right now. We don't need them. The base is the 13.7 and the triangle is 3 centimeters tall. So we're going to do half. Base is 13.7. Height was a 3. So now let's just crunch the numbers in the calculator. I'm going to do 13.7 times 3. And then because it's half, I'm just going to do divide by 2. So we get a 20.55 for the area of this triangle. 20.55 square centimeters. Now the base and the height for this one are a little bit trickier. Base and height of a right triangle are always just going to be the two sides that make the right angle. And to help you see it, I could just redraw it, where the 8 is here as a base and the height is here as the 8. And I don't care about the hypotenuse being the 11.3. Now the Pythagorean theorem, friendly reminder that the Pythagorean theorem says if I do 8 squared and add it to 8 squared, and then I do the square root of that thing, that's where they got the 11.3. But I don't need that for this problem. I don't care about that because we have the base and the height. We have the 8 and the 8. All right. So depending on how the triangle looks, you might need some help from me showing you what the base and the height are. But here we're just going to do half of 8 times 8. And y'all know that 8 times 8 is 64. So half of 64 would be a 32. There's nothing labeling this one, so I'm just going to put units. And that's going to be 32 square units for this square. If you wanted a reminder about why there's a 1/2, if it was the whole square, it'd be the 8 times 8, which is 64. But then the triangle I'm using, I only want this part of it, so I'm using the half, okay? All right, so that takes care of just the basic review of the formulas that you've probably seen in elementary school. Now let's kick it up a notch, okay? So let's flip over and kick it up a notch. So what if I wanted us to find the area of this weird thingy right here? Now you got a couple of options. Me personally, the way I see this is I actually see, if I split it like that, I see a rectangle right here on top of this square. All right. So that's one way to see it. And if I break it up that way, if I do 6 times 6, I get the area of this part is 36. Okay. And then right here, I can do this 2 times this 5, and this would be a 10. So the total area I'm getting here is a 46 square centimeters. Now, there is another way to break it up, and I'll show you right here. It might come more naturally to some of you to want to break it up with a line like this. In which case you now have, if you see it this way, it's a 4 by 6. So this is 24. And now we have this 2 by this 11. And 2 times 11 is 22. But if you add up 22 plus 24, we still get the 46. So it doesn't matter, y'all, when you want to break these shapes up. It really doesn't matter. It's however you as a student, how you see it. And this example right here is going to be another really great example for how to break these things up. The way I see it when I break this thing up, I see this. Okay, I see a big rectangle, and then I see a little rectangle here, kind of like the 2 flaps on either side. That's how I personally see it, okay? Now, if I see it that way, I have to get this length all the way across. Now, I know this much of it is a 3. I see a 3 right here, and I know this is 8. So 3 plus 8 so far right here, and I can trace it in green. This is 11, okay? This is 11. Again, I got 3 plus 8. This is 11. Now, plus this other 3. 11 plus 3. This whole thing is a 14, y'all. So this whole length is a 14. And now I can use my calculator to do the 8 by 14. And I get a 112 for this big rectangle in here. Okay? So it's 8 by 14. Now this is an 8 by 3. I know that these are 3s because of those little tick marks. So this would be a 24. And then this would be a 24. So we can just add them up. The 112 plus the 24 plus the 24. That's the total area of 160. Now, I think it's really common for a lot of students when you see this to actually want to break it up like this. I see this a lot. So I see the 8 by 3, which is a 24. A lot of students like to see it this way. Here's a 24, here's an 8 by 3, 24, and then here's an 8 by 3, 24. And then in here, it's an 8 by 8 square, so this is a 64. That also works. You can break it up like this, y'all. And then you've got 24. I'm just going to do times 4 because I see there's 4 of those out there. And when I do plus the square in the middle, see how I get the exact same answer? So you can break these things up however you want to break them up and find the little different areas. And then when you add them all together, we should get the same thing. Okay? Now for the semicircle. Okay, the semicircle. We know the area for circle is pi r squared, but that would be for the whole circle. And since I only have a semicircle, I just need to divide that thing by 2. Okay? So for pi r squared, 3.14, the radius of this thing would be a 3. That 3 is going to get squared. And that whole entire area for the whole circle, if that gives me this whole area, I'm going to cut it in half because I only care about this part up here. Okay? So I'm just going to cut that in half. That answer gets cut in half. All right, so 3 squared is 9. Now times 3.14. Cool. So the top part, the whole area of the whole circle would be a 28.26. Now I'm just going to cut that in half because it's half the circle, so we get a 14.13. We are done with that. I don't want you guys to think we have to do anything with the 6. I don't want you to mix it up with when we were doing circumference. When we did circumference, y'all, and we did the pi times diameter, that went all the way around. And I did have to cut it in half because I only cared about this part. And when I did circumference, then I had to add in the 6 because I cared about it. So I didn't want you guys to confuse the two topics. For area of the circle, you can just, when you find the area of the whole thing, just cut it in half and you are done. That's the area of the semicircle. And then it doesn't have any units labeled, so I'm just going to put square units. All right, so we're starting to see that you might need to break some shapes up or, find the area of a circle and cut it in half. And what if there is a missing side? Yes, you can still find the area because you can use the Pythagorean theorem. Okay, the Pythagorean theorem is a tool that I taught you all at the beginning of this unit. And now we're going to use that because we realize here for the area of this, it's half this base times the height, but I don't know this number down here. So I'm going to use the Pythagorean theorem and I'm going to do 7.5 squared minus 6 squared. I have the hypotenuse, so I just need to square it and subtract the other leg squared. So my 7.5 squared is 56.25. I'm going to minus the 36. Cool. So 20.25. Now I need to take the square root of that to get this base down here. So when I take the square root, I get a 4.5. So now we found this to be a 4.5. And now I can use my formula for area of a triangle and pull that down here. So for area of a triangle, it is half. The base I just found is 4.5. The height is a 6. And I know that half of 6 is 3, so I can just do 3 times 4.5 in the calculator. And I get a 13.5 for this. The area of this triangle is 13.5 square inches. Friendly reminder that when we had the triangle, the sides that made the right angle were the base and the height here. And since I didn't have that leg, I needed the Pythagorean theorem. If I go back to the other example we saw right here, this was a right triangle, and I had both of the legs to use for base and height, so I did not need Pythagorean theorem for this one. I had the base and I had the height. For the last example that I just covered, I did not have the base, so I needed to use the hypotenuse and this leg to find it. And since y'all know the Pythagorean theorem, that is fair game that you see this problem, and then you can go back to elementary school and find the area of this thing using this formula. All right, you guys are going to have some practice on the next page. That concludes this video. Thank you for watching.